Question number 1. When a wheel rotates about a fixed axis, all points on the wheel have. So wheel is a rigid object. When a rigid object is rotating, on every point on this rigid object will rotate with the same angular speed, same angular acceleration, same angular displacement. Yani rotational quantities are going to be same. So same tangential, this is linear quantity, no. Same arc length, this is linear quantity, no. Same angular acceleration, correct. Centripetal acceleration is also a linear quantity, they are different. So only C is the correct answer. Which of the following is wrong? The object rotates with a constant angular speed of 3 radian per second. Yes, this could be possible. An object can rotate with a constant angular speed. It's a scalar quantity, so we can say this. This is correct, but we are looking for wrong answer. This is not the answer. The car rounds the turn at constant velocity, rounds the turn. So this talks about circular motion. So for circular motion, object is direction of velocity continuously changing. That's why it's impossible to be constant. This is impossible because direction changes. So this is incorrect, yani wrong. So B is the answer which we are looking for. What about C? The athlete runs at constant tangential speed. Yes, tangential speed is a scalar quantity. That's why it can be constant if you fix it at 20 kilometers per hour. So in a circle, so it's going to be 20 every time. This is possible. Question number 3. An object moves in a circle at constant speed. In a circle, if an object moves in a circle, absolutely there is going to be AC. Constant speed, no AC, AT0. So, which of the following is not true? Yani wrong. A, its acceleration points towards the center of the circle. Because AT0, total acceleration is only AC. Yani A total is going to be only AC. So in which direction AC is, total acceleration is going to be in the same direction. So its acceleration points towards the center of the circle, correct. This is correct, but we are looking for incorrect answer. Its tangential speed is constant, its speed is constant. This is correct. So we are looking for incorrect answer. Its velocity is constant. This is not correct, because in a circular path, velocity is not constant. Direction of the motion continuously changes. That's why velocity cannot be constant. Incorrect. So this is the answer. Centripetal force acts on the object. Of course, if an object is moving in a circular path, centripetal force must act on the object. This is correct. So the choice is C, which is incorrect answer. Always an incorrect statement. D, which of the following sentences describes the path of a moving body whose acceleration is constant in magnitude at all times, but perpendicular to velocity? The only centripetal acceleration perpendicular to velocity is AC. Yani this object must be moving in a circular path. So answer circular path, circular path, circular path, circular path. Yeah, all are circular path. That's why. So we should check another thing. So whose acceleration is constant in magnitude? Yani AC is going to be constant in magnitude. It's going to be a circle, but AC is going to be constant. How is it possible? Because VT squared over R. If this number is constant, because for a circle R is constant, VT must be constant too. So if VT is constant, R for a circle is always constant, so AC is constant. That's why object must move with constant speed. The car is speeding up. No, speeding up causes an acceleration in T, so this is not the answer. The car is slowing down. No, it also causes an AC, so that's why that's why it's not constant. Speed cannot be constant, slowing down or speeding up. car is at constant speed in a circular path. This is the answer. If speed is constant, AC is also constant, of course, in magnitude, constant in magnitude, and moving in a circular path, C is going to be the correct answer. Constant velocity, impossible for circular path, so C is the correct answer for this question. A roller coaster car is on the track that follows a circular loop in vertical plane. If the car is just to maintain contact with the track at the top of the loop, what is the minimum value of the centripetal force? So this is a circular track. Question tells you that the car is just to maintain contact, means it's not pushing the track, but following the track. Yeah, there is not going to be a contact between it's not pushing the track. If not pushing the track, there will be no action reaction forces between the car and the track. So what force will be acting on the car? Only gravitational force, mg, will be acting on the track. So that's why gravitational force is going to be only centripetal force pointing in the center. Yani mg always downward, mg downward is the answer. So same question is asked in terms of acceleration. So in the above problem, Fc is on amg, on the centripetal force, gravitational force. So m times ac is going to m times g. M's will simplify. AC is going to be G only. So G is always downward, so G downward is the correct answer. Yeah, and 5 and 6 are in fact talking about the same thing in two different quantities. One of them is in terms of force, the other one is in terms of acceleration. Question number 7. Which of the following quantities may be calculated for an object moving on a circular path with a radius of r? R is given, and constant tangential speed v. Yani we know what r is, we know what v is, which one can be calculated. Tangential acceleration, there is no tangential acceleration, it is zero. You don't need to calculate this because constant tangential speeds, it's zero. Centripetal acceleration, yes, it can be calculated because it's moving in a circular path, and we can calculate AC by v squared over r. We know what v is, we know what r is, we can calculate AC. So B is correct. Angular speed, pardon, B is correct answer, but it's not only correct answer, maybe. That's why we should check the C. Angular speed, how can we calculate angular speed if tangential speed is given? Angular speed is going to be V over R. Yes, we can also calculate angular speed. So this is also correct. So B and C, yani D is going to be correct choice. In a popular amusement park ride, a cylinder is set in rotation at an angular speed. The floor then drops away, leaving the rider suspended against the wall in vertical position. What is the force that maintains circular motion of the rider? If the contact surface is vertical, and if an object is moving in a horizontal circle, so for the object, Fn is the only centripetal force. It's pointing in the center of the circular path. So normal force by the between the rider's clothing and the wall. So C is the correct answer. Question number 9. A copper block rests 30 centimeters from the center of a steel turntable. The turntable and the copper block rotate with the constant angular speed. What is the force that maintains circular motion of the copper block? Because copper block is on a horizontal contact surface, which is turntable, and it's moving on this turntable with a circular path. So because contact surface is flat, so static friction force is the only centripetal force for these types of questions. Question number 10. An airplane is flying in a horizontal circle at a constant speed. So Vt is constant. The pilot should not experience acceleration greater than 7 times free fall acceleration. So AC for the pilot is going to be 7 times free fall acceleration, yeah, 9.81, which is going to be 68.67 meters per second squared. So what is the minimum radius of the plane's orbit? R is the question. This question is one of the practice problems in the book. So AC is equal to VT squared over R. Because we are going to calculate R, we have to replace AC and R. R is going to be VT squared over AC. So VT is 105, we should square it, divided by AC, which is 68.67. We are going to use the calculator and find the answer. 105 squared divided by 68.67 is the answer. 160.5. 160 meter is the correct answer. 11. A girl at the state fair swings a ball in vertical circle at the end of a string. At the top of the ball's path, the net force that maintains circular motion. So when a ball is moving a vertical circular path, so attached to a rope at the top, at this position. So when the ball is at this position, two forces will be acting on the ball. One of them is the gravitational force. It's always acting downwards. Second one is the tension force. Tension force is always along the rope. Both are effective. Both are pointing in the center. That's why the resultant is going to be the centripetal force. And sum of force applied by the string and tension force and mg and weight of the ball. So B is going to be the correct answer for this problem. Mars orbits the Sun at a mean distance of r. Which one is the equivalent to centripetal force? That means the circular motion of Mars around the Sun. So Sun is at the center. Mars is revolving in elliptical path around the Sun. So circular motion will be defined for Mars. Of course, these two, Sun and Mars, will be attracting each other with gravitational force, Fg. This force acts on Mars and also acts on Sun. But Sun is not in circular motion due to the Mars pull. Mars is in circular motion due to the Sun's pull. So then centripetal force for the Mars is going to be the gravitational force between the Sun and the Mars, capital G, mass of Sun multiplied by mass of Mars divided by radius of the orbit, which is the distance between the Sun and the Mars squared. So correct answer is going to be B for this question. Question number 13. Mars orbits the Sun at a mean distance of 2.28 times 10 to the power 11 meter. Calculate angular speed of Mars around the Sun. Angular speed can be calculated delta theta divided by delta t one way. But in here, as you see, there is no delta t given, there is no delta theta given. So we can use an alternative method. Another method is using the centripetal force equation, because I know for Mars, gravitational force between Sun and the Mars is going to be the centripetal force. Yeah, Fc is going to be Fg. Fc, we know, because Mars is in circular motion, Mars mass multiplied by radius of the orbit multiplied by angular speed square of Mars, which is centripetal force of the Mars, is going to be equal gravitational force, G, universal gravitational force, mass of Sun, mass of Mars, divided by separation between them, R squared. So this mass of the Mars will simplify. These are transferring here, it's going to be R cube. So omega squared is going to be capital G, mass of Sun divided by cube of the separation between Mars and the Sun. After that, let's calculate omega squared. Capital G is 6.67 times 10 to the power of negative 11 times. Mass of Sun is 1.99 times 10 to the power of 30 divided by cube of the distance between them, 2.28 times 10 to the power of 11 cube. So we are going to apply the calculator. 6.67 times 10 to the power of negative 11 times 1.99 times 10 to the power of 30 divided by bracket 2.28 times 10 to the power of 11 close bracket cube. So answer and omega squared is going to be 1.12 times 10 to the power of negative 14. When we take the root of answer, omega is going to be 1.06 times 10 to the power of negative 7 radian per second. Yani A is going to be the answer. So Mercury revolves around the sun at the rate of 2.877 times 10 to the power negative 7 radian per second. This is omega of Mercury. Calculate the length of 1 year of Mercury in Earth's days. This time I can use omega delta theta over delta t equation. When it solves about the length of the 1 year, and its question is delta t, find delta t, we can find delta t is going to be delta theta over omega. For one revolution, because 1 year is the time for one revolution has an angular displacement 6.28, divided by angular speed of for this one revolution, 2.77 times 10 to the power of negative 7. You should just take the bracket. Then you will find the time in seconds. So 2.77 times 10 to the power of negative 7. Answer is going to be delta t 22 622 671 48 seconds. This is seconds. We'll convert seconds to hour or days. First, divide by 60, convert minute. Divide by 60, convert hour. Divide by 24, convert days. And delta t is going to be 262 days. So this is the correct answer. So question number 15, why does the moth fly off a rapidly turning wheel? First answer, why moth turns on the surface of the wheel when it is not rapidly turning? So some force must be keeping it on the circular path and it makes sticks on the surface of the wheel. That force is the adhesive force, which is the between the mud and the wheel. If this force, which is the centripetal force, is not big enough, in this case, the mud will follow not circular path, straight line path, and will leave the rapidly turning wheel. So B is the correct answer. Question number 16, what is the condition for the water to remain in a pail wheel in a vertical path? So this case is very similar to roller coaster car turning inside, because water is also, when it's upside down, water is moving in a similar way how the roller coaster car turns inside a track. So in this case, gravitational force will be acting towards the center. One more force possible to act on water inside the pail, which is Fn. But Fn exists if you move this pail with a big speed fix. So when speed decreases, this Fn also decreases. Finally, when speed gets minimum value, Fn becomes 0, only centripetal force becomes gravitational force. Yani, when you move this pail at minimum speed, centripetal force becomes gravitational force, and centripetal force m times ac, gravitational force m times g. This m is water, or next to water, they will simplify. AC is going to be g. So AC is equal to g, or AC can be greater than g. If AC is greater than g, in this case, Fn appears. But AC cannot be less than g. This is impossible. In this case, water will fall from the bucket. So centripetal exertion of the pail must be equal to free fall exertion, correct. Centripetal exertion of the pail must be greater than free fall exertion, also correct. but it cannot be smaller than that. So both A and B are correct answer. Question number 17, in which case the water in a pail will not remain in the pail? When it's filled, just we explained, if AC is less than G, it's impossible. So C. Which of the following actions does a car gain an acceleration? Does a car gain acceleration? Acceleration, you know, can happen by two ways. Speed change, and you can push the gas pedal or you can brake the car, or direction change. Speed change, as I said, pushing gas pedal or brake pedal. Direction change, steering wheel. So all of them produces acceleration. Two of them, A and B, produces tangential acceleration. Spinning steering wheel causes centripetal acceleration. So all of the above are correct. An object moves in a circular path with constant tangential speed v. Circular path with v, constant tangential speed. So object's velocity is constant. This question, I think I asked a while before. Its velocity cannot be constant in circular path because direction change. This is not correct. Object's angular acceleration is constant, greater than zero. There is constant tangential speed means h is zero. So it's not greater than zero. Zero. Not correct. Object centripetal acceleration is zero. Impossible. In circular path, AC cannot be equal to zero. Not correct. Object's resultant and total acceleration is constant in magnitude. Yes, correct, because total acceleration is in this case going to be equal only AC because AT is zero. AC depends on V squared over R. R is unchanged. V is unchanged and constant. That's why A total is going to be in this case unchanged and constant in magnitude. Question number 20. A roller coaster car speeds down a hill and past point A as shown above. So questions about point A. At point A, centripetal force is zero. Impossible. It's moving a circular path. If moving the circular path, centripetal force points upward towards the center because center is above. This is not correct. Centripetal force at A is upward, correct, and equal to addition of the normal force and the mg. Normal force, because car is above the truck, normal force will be acting towards the center. Gravitational force will be acting downwards. Centripetal force is going to be resultant of them, Fn minus Fg, not addition, addition plus. This is correct, but second part is incorrect. That's why not correct. Centripetal force at A is upward and equal to difference and subtraction between the normal force and mg. This is correct. Centripetal force at A is downward, impossible. Circle center is above. That's why it cannot be downward. Question number 21. A pilot is flying at 30 meters per second in a circular path with a radius of 100 meters. So this is Vt. This is R. A force of 630 Newton is acting needed to pilot circular motion, and Fc. What is pilot's mass? This is one of the questions, I think, sample or practice problem. So Fc is equal to m times Vt squared over R. I will calculate m, so you have to transfer Vt squared over R by flipping the other side. It's going to be Fc times R divided by Vt squared, is mass. So m is going to be Fc 630, R is 100, Vt squared 30 squared, so let's get it. 630 times 100 divided by 30 squared, which is 70. 70 kilograms is the answer. Why does an astronaut weigh less on the moon than the Earth? Weight is equal to m times g. Astronauts' mass cannot change, but weight can change because g affects the weight. Moon has less free fall acceleration than g, Earth. So astronaut less mass than on the Earth. No, mass doesn't change. The astronaut has more mass on the Earth. No, doesn't change. Gravitational field strength is less on the moon surface than the Earth. This is correct. G is small on the moon than Earth. Astronauts floating around inside space shuttle are not actually the zero gravity environment. What is the real reason for astronauts seems like this? Weight can be felt by a person if Fn acts on this person's body. When you are on the seat, on the table, on the chair, so this is your body saying that your body is pulled by the earth, Fg. This Fg causes a force acting on the chair. Chair pulls you back, Fn. You are feeling, in fact, this Fn, and this Fn is equal to Fg because you are in equilibrium. You indirectly measure Fg by Fn. But when you are, say that, jumping from window with your chair, so both chair and you will be falling with G. No one will push one another. Yeah, you are not going to push the chair. There is not going to be action on the chair. There is not going to be reaction in your body. And Fn is going to be zero. That's why when you're jumping from the chair with your chair, you cannot feel your weight. Similarly, if a space shuttle falling down the ground with acceleration of the gravity, in this case, you are falling with G, space shuttle is falling with G, no one pushes one another, Fn is going to be zero, even though you have Fg acting on your body, but there is no Fn, so you cannot feel your weight, you seem weightless, and A is the correct answer. Question number 24. Which one is correct about Earth? Earth is a perfect sphere in shape, no. Earth bulge at the poles, no. Earth bulge at the equator, this is correct answer. This is correct answer. It's one of the chapter question. Question number 25. A mass is attached to 50 centimeter long, moving on a circular path starting from base, yani omega initially zero, and completing 43 turns, which is delta theta, in 1 minute, which is delta t. What is the average angular speed of mass during 1 minute time interval? Omega average is the question. We calculate omega average by delta theta over delta t, remember. Omega average. Delta theta is 43 turns. Of course, every turn is 6.28 radian, divided by delta t, which is 1 minute into second, 60. So 43 times 6.28 divided by 60 is the answer, which is 4.5. 4.5 radian per second is going to be average angular speed. 26 is similar but different question. MS is attached to a string 50 centimeter long, moving a circular path starting from base, yani omega initial is 0. Completing 43 turns, yani delta theta, in 1 minute delta t. What is the tangential speed of the mass after 1 minute? This is not about average, this is about instantaneous speed, tangential speed. V final is the question. But to calculate V final, we should calculate omega final. So we are going to use the equation delta theta is equal to 1 over 2 omega initial plus omega final times delta t. Delta theta for the 3 turns, of course, you should multiply by 6.28, is equal to 1 over 2. Omega initial is 0, no need to write. Multiply omega final is the question. Delta t is 60 seconds. So now we can calculate omega final. 43 times 6.28 is 270. Multiplied by 2 cross product, divide by 60. So omega final, you calculated 9 radian per second, but not meter per second. This is radian per second. The final is going to be, of course, this object is moving in a circular path. Tangential speed is going to be r times omega final. So you are going to multiply r, which is 50 centimeter, 0.5 by 9. Result is going to be 4.5 meter per second. So this is the correct answer. 27. A car is traveling at 12 meters per second, which is the initial, undergoes a constant negative acceleration of 2.1 meters per second squared. This is linear acceleration, A, because it's negative 2.1, we have to write it when the brakes are applied. What is the angular speed of the tire after 10 revolutions? Given Displacement is angular displacement, delta theta, but it's in revolution. Assuming that the car does not skid and tires have a radii of 30 centimeters. And you are going to calculate final angular speed. You find omega final, but half of the quantities are linear, half is rotational, but ask is rotational. Better to convert the initial to omega initial. For a rolling object, because tire is rolling, we know if you divide linear quantities by r, you will calculate rotational quantities. Yeah, 12 meters per second divided by radius of two tires 0.3, which is going to be 40 radian per second. And also calculate alpha, which is AT divided by R, linear acceleration divided by R, which is 2.1 divided by, which is negative, of course. R is 0.3, which is going to be negative 7 radian per second squared. Now we can apply the kinetic equations. I will calculate omega final. I know delta theta, so I'm going to use fourth kinematic equation. The final squared is equal to the initial squared plus 2 alpha delta theta. Omega final squared is equal to omega initial is, we just found 40 radian per second squared plus 2 alpha is negative 7 delta theta is 10 revolution. Every one revolution 6.28 radian. So omega final squared, let's calculate how much. 40 squared plus 2 times negative 7 times 10 times 6.28. Answer is 721. This is omega squared. So we should take the root. After taking the root of the answer, you will get 26.8. Omega final is 26.8 radian per second, which is going to be B. And 28, an airplane is flying in a horizontal circle of radius of 150 meters. The pilot is 80 kilogram mass, experiences centripetal acceleration 7 times free fall acceleration. So AC is going to be 7 times 9.81. We did this before in the classroom. It is 68.67 meter per second squared. How many revolutions does an airplane complete in 1 minute? So delta theta is the question. In 1 minute, delta t is equal to 60 seconds. So AC is given, R is given. How many revolutions are asked? Delta theta is asked. It's moving in a circular path. With constant tangential speed, it's better to write here, if constant speed. So we are going to use this equation. Omega average is equal to delta theta over delta t. If I want to calculate delta theta, I have to find omega multiplied by delta t. Delta t I know, but omega must be calculated. I can calculate omega from given centripetal force equation. AC is equal to R times omega squared. So omega squared is going to be AC divided by R. AC is 68.67. R is given as 150. We will calculate omega squared first, which is going to be 68.67 divided by 150, which is omega squared is equal to 0.4578. After that, take the root, get omega. Omega is 0.68. Yani angular speed is going to be 0.68 radian per second. And we can apply the equation. Omega is 0.68, delta t is 1 minute 60 seconds times 60, 40 6 radian. What choices are given in revolution? Divide by 6.28. It's going to be 6.5. Yeah, when we round it, delta t is going to be 6.5 revolutions. B is the correct answer. And 9, Earth orbits the Sun every 365.25 days, which is delta t for 1 revolution and 1 year. Once 1 revolution, angular displacement is 6.28 radian. At a mean distance, separation between the Earth and the Sun is this. Calculate the centripetal acceleration of the Earth about the Sun. AC is the question, which we know R times omega squared. R is given, but omega must be calculated. We can calculate omega because Earth complete once and 1 revolution, which is 6.28 radian in 1 year, 365.25 days. Of course, we should convert this to first hour, then seconds. So we'll find omega. 6.28 divided by 365.25 times, position bracket in denominator, 24 times 3,600, close the bracket. Answer is 1.99 times 10 to the power of -7 radian per second. Then now we can apply this equation for calculating AC. R is 1.5 times 10 to the power of 11, which is distance from the Earth to the Sun, times 1.99 times 10 to the power. And last question, a building superintendent twirls exit of case in circle with at 5.2 radian per second. If the case have the tangential speed of Vt 8.5, calculate centripetal acceleration. AC is the question. So I know AC can be calculated R times omega squared, but AC at the same time equal to R omega times omega, the omega squared. This is a R times omega Vt. Yani I can also calculate AC by tangential speed times angular speed. AC. Tangential speed is given 8.5. Angular speed is 5.2. You can find it. So 8.5 times 5.2, answer is 44.2 meter per second squared is the correct answer. This is all about doing assess test number 11.